this section 2.6, we will see how the measures of center, the mean, the median, and the mode are affected by the shape of a distribution, which can be a symmetrical distribution or a distribution that is skewed right or left. So here is an example. We have three groups: statistics students, English students, and geography students, and we asked them how many hours they slept last night. And the statistics students said 4, 5, 6, 6, 6. I see here 6 students said that they slept 7 hours, 3 students said that they slept 8 hours, 1 student said 9, and 1 10. Remember, histograms have their rectangles attached to each other. So I have a frequency of 1 for 4 hours of sleep, a frequency of 1 for 5 hours of sleep, a frequency of 3 for 6 hours of sleep, a frequency of 6 for 7 hours of sleep, a frequency of 3 for 8 hours of sleep, a frequency of 1 for 9 hours of sleep, and a frequency of 1 for 10 hours of sleep. This is a symmetric distribution. If I fold it, it will fall almost on itself. So the end values 4 and 10, 5 and 9 have all equal frequencies, 6 and 8 have equal frequencies, and the middle, which is 7, has the highest frequency, and it falls on itself. For English, I had one student say 4 hours of sleep, one student say 5 hours of sleep, 3 students say 6 hours of sleep, 4 students say 7 hours of sleep, and 1 student say 8 hours of sleep. This distribution is skewed left. Skewed left means that a lot of the data are towards like the upper values, 6, 7, and only 1, 8, but very few data create a little tail in the graph of lower values. In geography, one student said that they slept 6 hours. Four students said that they slept 7 hours. 3 students said that they slept 8 hours. 1 slept 9 and 1 slept 10. This distribution is a skewed right distribution because most of the values are clustered towards the left, 7 and 8, and only 1, 6. And then we have a tail going to the right. I created those frequency distributions in Excel. I put my data here, and then I created the histograms in Excel. And we have seen how to create histograms in previous videos. Now what I want to do is I want to calculate the measures of center for these distributions, the mean, which equals to the average of the data values in statistics. And I'm going to copy this formula over to the next column and to the next column, and Excel will transfer everything to the right. The median equals median of those data values. And again, I'm going to copy and paste, and Excel will just calculate it over. And the mode equals the mode. I don't need really to do that. If I have created the histograms, I can see the mode. It will be the value that has the highest rectangle in the histogram. And for the symmetric distribution, the mean is 7, the median is 7, and the mode is 7. So this is a symmetric distribution. The mean was 7, the median was 7, and the mode was 7. The second was skewed left. It has a long tail extending towards the smaller values. and that the mean was 6.3, the median was 6.5, and the mode was 7. And I can see that the mode is 7 because it corresponds to the tallest rectangle in the distribution. And the third one is skewed right. And I can see the mode just from the graph. I don't need Excel to tell me. The mode is 7. The mean and the median, I didn't want to spend the time to do it, so I used the technology. The mean was 7.7 and the median was 7.5. And the observation that we make is that the relationship between the mean, the median, and the mode is that the median, which is the middle of the data, is always between the mean and the mode. So the median is always in the middle. It's in the middle of the data. It's also in the middle of the measures of center. In a symmetrical distribution, the mean, the median, and the mode are equal to each other. In a skewed right distribution, the mode is smaller and the mean is the largest. That means the tail takes the mean with it. The median stays in the middle between the two. And in the skewed left distribution, the skew will skew the mean. So the mean will be to the left, which means the mean will be smaller, the mode will be the larger, and the median will stay in the middle. Remember that the mean is not a resilient statistic. So it is affected by the unusual values in the tail, which is the skew. So if your unusual values are small, your mean will be small. If your unusual values are larger values, then your mean will be the larger one. So discuss or think about the mean, the median, and the mode in each of these distributions. Pause the video and then reopen the video to see if you correctly guessed what is the skew of the distribution and what is the relationship between the mean, the median, and the mode. The distribution on the left is skewed right. I see some unusual values that are really high. This means that the mean will be in that direction. Therefore, the mode is less than the median, is less than the mean. The mode being the most popular value. The next distribution is skewed left. I see a tail in this direction towards the lowest values. That tail will take the mean with it. So the mean will be smaller, and then the median will be in the middle, and the mode happens to also be in the range of the largest values. The next distribution looks approximately symmetric. It's not exactly symmetric, but I'm expecting that the mean, the median, and the mode will be very close together. And of course, I will need technology to calculate the exact values. For this particular section, the glossary is includes the terms like the mean, the median, the mode, what is a symmetrical distribution, and what is a skewed distribution. Also, how does a skew affect the relationship between the measures of center?